Hi guys, I hope you're doing well. And this is organic chemistry. Once again, I want to show you something about resonance patterns and structures. I have 5 bullet points, and I think this is very important because it shows up throughout the semester 1 and 2. I have this summary of all the patterns: allylic lone pair, allylic carbocation, lone pair adjacent to a C plus, pi bond between two atoms of differing electronegativity, conjugated pi bonds enclosed in a ring. And I have written also how many arrows it takes for each one of the patterns. 2 arrows, 1 arrow, 1, and the last one I think is 3. So let's dive into it. First pattern is allylic lone pair. Let's just remember quickly what is benylic and what is allylic. Benylic is right immediate to the pi bond, and allylic is 1 carbon away from the pi bond. In this pattern, we're gonna use 2 arrows. The first one going from the lone pair to then the second one from the pi bond. So you can see the pattern, and it's always starting from the lone pair and then from the pi bond. It's like a shift of locations where the pi bond is now the lone pair, and where the lone pair was, now we have a pi bond. Second bullet point is the stop right there. So let's just give it a second. And then an allylic carbocation. So before it was a lone pair, now it's a carbocation. And we're gonna start drawing the arrows from the pi bond towards the positive charge. Notice I have a note: never place the tail of a curved arrow on a positive charge. So the positive charge is gonna shift to where the pi bond was. Once again, change of energy, change of location. Pattern number 3, a lone pair adjacent to a C plus, to basically a carbon cation again, but now instead of a pi bond we have a lone pair. And what's gonna happen, we're gonna form a pi bond between the lone pair and the positive charge. It's only gonna take 1 arrow, and it starts from the lone pair towards the positive charge. Pattern number 4, a pi bond between two atoms of differing electronegativity. We're going to focus on carbon oxygen and nitrogen oxygen double bonds. One arrow once again, and you can see the charges are there, positive and negative, but since they're one positive and one negative, they cancel each other, and it's the same as the first molecule. It's still neutral, and it goes from the pi bond towards the most electronegative atom, in this case nitrogen or oxygen. Last but not least, conjugated pi bond in a closed ring is going to take 3 arrows, and it's a shift of all the pi bonds where the pi bond was. Now we're gonna have a sigma bond. Let's just number them so it's easier to see the differences. As you can see, I didn't really draw different molecules, so I'm gonna draw it again. Let's say if it was in 1 and 2, now it's gonna be in 2 and 3. If it was between 3 and 4, it will be now between 4 and 5. And if it was between 5 and 6, it will now be between 6 and 1. Well, that's all I have to say. I think it's worth memorizing these 5 patterns. The more you practice, the more that it's easier to remember. This shows up in 2 semesters, like I said. It's really worth it. Thanks for watching.